Today we're going to learn synthetic division, which some people prefer synthetic to long division. I really like synthetic division because it's a series of multiplication and addition instead of subtraction. I don't like subtraction very much, so synthetic division gives us the opportunity to add, which means that we can do a little bit more of it in our head and maybe trust our mental math a little bit more. The one problem with synthetic division is that it only works for specific types of polynomial division. It only works when you are dividing by a binomial that looks like this. So a 1x plus or minus a number. There can't be a number in front of your x. There can't be a coefficient in front of your x. And you can't divide by x squared. You have to only divide by a binomial like x minus 5. First thing you always do, doesn't matter what type of division you're working with, you always have to check for missing terms. If we're starting with x to the third, we need to make sure we also have x squared and x and then a number. And if we're missing any of those, we need to put a zero term in its place. This one is not missing anything, so we're good. For synthetic division, you write the coefficients in the division problem. So I've got 3, negative 17, 15, negative 25. And then it's like an upside down division bar. You need one line of space underneath those numbers. The other weird thing about synthetic division is that we aren't going to use negative 5. We are going to use positive 5. So you're basically finding in this binomial what value would make that binomial equal 0, and that's what you plug into synthetic division. So because it says x minus 5, we are going to use positive 5, because 5 minus 5 would give us 0. For synthetic division, you always start by bringing this first number down to the bottom. You have to have a number at the bottom to work with. We are going to multiply the 5 with whatever number is on the bottom and write that number up in the next spot. So what is 5 times 3? 15. We write that here. Then we add these numbers together. Negative 17 plus 15 is negative 2. Now we multiply. 5 times negative 2 is negative 10. And then we add 15 and negative 10 gives us 5. Multiply. 5 times 5 is 25. And then add negative 25 plus 25 is 0. This number is going to be your remainder. So in this case, we don't have a remainder. The rest of this is our answer. This 3, negative 2, and 5, that gives us our answer, but we have to figure out how to write it. The 5, the number before the remainder, that's always going to be your plain number term. The next one to the left will be your x term. The next one to the left will be your x squared term, and so on. So we have 3x squared minus 2x plus 5. The other way to remember this is we started with 3x to the third, and we just divided one of those x's out of it, so now we have x squared as our first term. If we had a remainder, we would add the remainder over what we originally divided by. But what is 0 divided by anything? 0, so we don't need to write that term on there. This is our answer. Okay. Now, this first time I did this, it looks really messy. There's a lot of arrows. There's a lot of mumbo jumbo in there. As you get better at synthetic division, you won't need to write all of that stuff. So let's take a look at the next one. First of all, check for missing terms. We're starting with x to the fourth. So next we need x to the third. Do we have an x to the third term? No. So right above this, I am going to write 0x to the third, and then negative 10x squared minus 2x plus 4. So the only missing term is the x cubed term. So we have 1x to the fourth, 0x squared, negative 0x to the third, negative 10x squared, negative 2x, and 4. So this is our x to the third term, this is our x squared term, x, and our number term. I messed that up, didn't I? Yes, I did. Ignore me. This is the x to the fourth term, x to the third term, x squared term, x term, and number term. All right. And I always drop that first number down because we have to have something to start with. What do we need to write here? Negative 3. Because we're dividing by x plus 3, we are going to use negative 3 in synthetic division. Okay, multiply. Negative 3 times 1, negative 3. And then add. 0 plus negative 3 is negative 3. Multiply. Negative 3 times negative 3 is positive 9. Add them. Negative 10 plus 9 is negative 1. Multiply. Negative 3 times negative 1 is positive 3. Add 1. Multiply negative 3 times 1 and add, we get 1. This last number is our remainder. The next number to the left is our number term. The next number would be our x term. The next one would be x squared. The next one would be x to the third. Or, because we started with x to the fourth and divided by an x, our first number is going to be the x cubed term. So we have 1x cubed minus 3x squared minus 1x, or just minus x, plus 1. And our remainder is 1 over what we originally divided by. Try example 3 on your own. First, check for missing terms. Are there any missing terms? No? So set up synthetic division and try this one on your own. So when we set up synthetic division on this one, drop the 4 down. Negative 2 times 4 is negative 8. That adds to 0. It is okay to get a 0 down here at the bottom. Negative 2 times 0 is 0. Add to get negative 9. Negative 2 times negative 9 is 18. So we have a remainder of 0. The term on the right at the bottom is your remainder. The next term to the left is the number. The next one is your x term, and the next one is your x squared term. So we have 4x squared plus 0x minus 9, and our remainder is 0 over what we originally started with. Now, I wrote everything out. Do we need to write this remainder at the end? No, because it's a 0. Do we need to write the 0x term? No, because it's our answer. Our answer is 4x squared minus 9, which we actually could factor more. We could actually fully factor this one. It'd be really fun, but we'll save that for another day.